In this session, we will discuss about different techniques of clustering, how to group the data items depending upon different parameters, different features, and with different data sets, we will see how to make clusters or groups of the data items. Whether you are working on image data set, text data, or numeric data sets in pandas data frames, in multiple formats, in multiple data types, we will see how to implement clustering algorithms. Along with description of clustering approaches with live demonstration mode, we will discuss about performance evaluation for effective results, how to evaluate the performance of clustering approaches, because you might have seen that clustering is unsupervised approach, there is no labeling, so it becomes quite challenging to analyze whether clusters are effective or not, whether clusters are correct or not. So we will see how to check performance, whether these are created properly or not. So there are different techniques, there are different mechanisms for formation of effective clusters, and in formation of effective clusters there is one more approach, one more mechanism that is known as IQR analysis. We will discuss about this part also with practical demonstration, how to work on interquartile range IQR analysis, so that we will be able to form better clusters by removal of noise in advance. As far as clustering is concerned, there are different types of clustering algorithms, clustering approaches: partition based, hierarchical, density, grid based clustering. In this particular session, we are focusing on partition based clustering, K means approach, and in density based clustering, we will discuss about DBScan algorithm to verify and allocate the data items depending upon the closeness. As far as K-means algorithm is concerned, in that case we go for multiple clusters. We have to decide a number of clusters, and with some mathematical operations we allocate the data items in particular cluster. In case of density based clustering, we will see closeness, by which way a specific data item is associated with other in terms of specific mathematical metrics. So these two algorithms we will discuss with practical demonstration. Before covering the algorithms, K-means and DBScan, first of all, very quickly we will see different characteristics of clustering, and along with that, in broader way, how many clustering techniques are available. So as far as clustering techniques are concerned, obviously it is covered under unsupervised approach. There is no label, and there is no predefined label or target. So when we form some specific cluster, it becomes very challenging, very difficult to check whether cluster formation is good or not. If we relate it with image processing, for example, you are working on quantization, because quantization, image quantization is also a type of clustering. So in that case it becomes very challenging to check whether a specific quantized image is correct or not, or to how much further level it can move. In similarity points, in similarity aspect, we have to see which particular data items are more similar to each other, and there is no thumb rule. We have to see which particular technique we have to adopt, whether hierarchical or density based or distance based. So these are certain characteristics, and depending upon distance, depending upon density, depending upon some specific association, we decide these data item to be allocated to specific cluster. Okay, and definitely there should be interpretability. So last point, you can see the formed cluster should be having some specific use case. Whatever clusters we are forming, whether you are working on sentiment data analysis, for example, you have sentiment data, you are having some sentences, some documents, and you want to make some particular clusters of documents. So those particular clusters of documents or sentences should be having some specific use case, it should be having some application. Okay, and it should be understandable, it should be realistic. Or for example, if we take scenario of emails, so there are different types of blocks, spams, okay, bulk mail. So whatever mails are coming in spam in a particular cluster in a specific form, whether these are actually spam or not, it should not happen that actual mails are moving to the spam folder. Okay, because that is also a use case of cluster formation or clustering algorithm or association. However, it is related to text based analysis, because email body, whatever text is written in email, that is in text format. So at the back end, mail servers apply some algorithms to identify whether these are associated with some spam or bulk mail, or these should be associated with some specific inbox. Okay, so you can see that there are different distance measures. We will discuss about these parts when we will cover DBScan algorithm in broader way. In iBird view, there are two types of cluster formations, clustering techniques. One is hard clustering and second is soft clustering. Depending upon our research objectives, we have to decide which specific algorithm we have to take, or whatever data we are taking, how many clusters we have to form. In case of hard clustering, one sample or one data item is associated to single cluster only. That is hard clustering. It means one to one relationship. One data item, it is associated with one cluster. In case of soft clustering, there may be multiple clusters. Okay, it means single value, single data item may be associated to multiple clusters. So that is soft clustering. Okay, so depending upon our research objectives, depending upon our data items, in whatever format we are working, for example, we have some data set related to education, academics. So in that case, some students may be in sports, some students, same number of, same type of students, or same attributes of students may be associated to academic activities. Okay, to extracurricular activities. So that will be covered under soft clustering. In hard clustering, straightforward single cluster formation. Okay, so these are two broad categories, and we have to see our data item, we have to see our research objectives in which we have to work out. Okay, so in case of hard clustering, you can see that each data point belongs to exactly one cluster, and its example algorithms, K-means and DBScan algorithm, we will cover today in this particular segment. No overlapping between clusters. Okay, so if a particular data item is meeting certain criteria to be associated with a specific cluster or specific group, it will be associated. Okay, so for example, we have a data set related to some sports activities. Okay, uh, some players attributes, some features of players, some features of those sports persons we want to allocate. Okay, so either we can use k-means clustering or we can use DBScan. Okay, lots of other algorithms available in hard clustering. Okay, single cluster and its associated values are unique. As far as soft clustering is concerned, it is probability based, expectation maximization, GMM algorithm, EM algorithm. Multiple approaches are used in case of soft clustering, in which the data item or data point may be belonging to multiple clusters with probabilities. Okay, that this particular data item, this specific data value is may be associated with multiple clusters or multiple groups on the basis of their probability, that 60% chance of being in cluster 1 and 40% chance of being in cluster 2. Okay, it is not under true and true false. In case of hard clustering, we work with true false, yes no. Okay, whether it is associated or not. In case of soft clustering, we find out, we calculate the probability, and after that we move ahead for cluster formation. Now we will see, once the algorithm is decided that we want to work with hard clustering, we have certain data set, and that particular data set we want to pass to some particular algorithm, whether DBScan, K-means, EM, so many other approaches available. Okay, so you can see that on which basis we have to decide whether hard clustering is appropriate or soft clustering. Okay, so you can see that as far as flexibility is concerned, hard clustering is having strict groups. Okay, so where to use hard clustering? Where the clusters are clearly separable. For example, some particular data set in which we want to we want to allocate a demarcation line, that these two sets we want to decide, these 2 points we want to decide. Okay, in case of soft clustering, we go for probability evaluation, and data overlapping may be there. For example, if we are taking a scenario of sentiment data analysis, in one particular statement it may be associated to some specific emotion or multi or different types of emotions. For example, 2 to 3 emotions we have decided. So a specific sentence, a specific statement is coming, or it is lying in two different emotions. Okay, if you take some specific data set like movie lens data set, if you take data set related to some specific web series, in that case also you might have seen different categories are associated, like comedy or some particular war state movies or some other type of. So one particular movie, one specific web series may be associated to different clusters if we are using soft clustering. If we want that, okay, we want to decide only single cluster, in that case we will use hard clustering. Is it visible and clear to all participants? Kindly confirm. Up to now, whatever we are discussing, is it visible and clear to all of you? In chat window, kindly confirm.
Yes, sir.
Okay. Okay. Now, dear participants, we will see, we will move ahead with our content. Before applying any clustering algorithm, first of all, we have to work on a specific technique, a specific approach that is known as IQR analysis, interquartile range. Okay, whether you are using K-means algorithm, DBScan algorithm, or any other algorithm, this point is very important. You might have seen in this particular STC, certain concepts were already covered related to data pre-processing or data preparation. Whether you are working on machine learning, deep learning, or any other approach, you are working on data analytics. Before working on the actual data, first of all, it must be pre-processed. If we take the data from any source, whether it is primary source or secondary source, and we are passing it directly to k-means or dbscan or emm or gmm or whatever it is, any algorithm, definitely you will get clusters. There is no problem. Okay, so this is clustering approach. Unsupervised, in unsupervised or in supervised, in whatever technique you are passing your data without pre-processing, in that case definitely you will get some results. Okay, many times we feel happy that I'm getting this much accuracy, 99.9% accuracy or 94% accuracy, but without data pre-processing, the results will be very very bad, even if we are getting high accuracy. In case of clustering, there is no concept of accuracy. You might have seen, if we are working on unsupervised approach, there is no concept of confusion matrix. We do not work on error factor because we don't know its labels. In clustering approach, there is no mechanism, there is no hard mechanism to calculate accuracy, whether clusters are good or not. We have to assume, or with certain techniques, we will discuss about those techniques also. Silhouette technique, Silhouette method, so many other techniques available. But directly or straightforward way, it becomes very difficult to find out whether our clusters are good or not. So in that case, what we do, if we are able to pre-process our data effectively, then our clusters will be definitely very very effective. So what is which particular techniques we use for data pre-processing in clustering? This is the major technique, interquartile range, to find out whether the data is suitable or not. However, in clustering technique, there is a particular term you might be already knowing, that is known as outlier. Okay, in clustering, for example, we are forming some clusters, then if some particular value is abnormal, if some particular value or item is out of range, or some it is having some abnormal point, in that case we assume that okay, if there is some anomaly, if there is some unwanted value, it will go to that outlier. But in k means, you might have seen, if we are not working on interquartile range, in that case centroid will be calculated from that outlier also. Because when we apply centroid, when we apply dbscan or any other technique, in that case you might have seen in every iteration some calculations are done. If we are having some value that is out of bound, that is that that is abnormal, in that case centroid will be calculated from that abnormal value also. And if we are calculating centroid repeatedly from that abnormal value, definitely you can imagine what will happen to the final clusters. That particular abnormal value will try to allocate itself in some cluster. Okay, and what will happen in that case, we will be having very bad clusters. Okay, it will distort cluster centers. So you can see that what will happen if we skip iqr, extreme outlier affect clusters. In k means centroids are pulled towards extreme values. Okay, we will discuss about that part also. about centroid, by which way centroid is calculated, by which way distance is calculated. But broadly we are discussing here, if we are having certain value that is out of bound, that is abnormal. For example, I am having only four values, 1, 3, 5, and 100. In that case, if 135, okay, these are similar values, these are nearby value. But what about 100? If I do not apply IQR, in that case centroid will be calculated from 100 also, by taking in consideration 100 also. But if I am using IQR, in that case IQR will remove 100. So I will pass only 135 to k-means algorithm rather than 13500. In the same way, for example, I am having some data values 1, 1, 2, 3, 5, 25. Without IQR, 25 will be taken into consideration, and centroid distance will be calculated from 25 also. And 25 value will try to allocate itself in some cluster, but we already know that it is an outlier. But okay, these are only 4 to 5 values. Okay, in 4 to 5 data items, in 10 data items, 20 data items, we can check. But if we are having a big data, for example, I am having 1000 records or 5000 records, in 5000 records it becomes very difficult to see outlier. So what we do in IQR analysis, we check what is the outlier value, what is the extreme outlier. Okay, so what will happen, case A, k means without IQR, centroid calculation includes 100 if I am not using IQR. Because so whether you are using image processing, or you are using deep learning, or you are using reinforcement learning, generative AI, large language model, in almost every technique we have to perform data pre-processing, data preparation. Okay, so we, rather than taking data, for example, we have taken data from benchmark sources, IEEE data port, from UCI machine learning repository, and directly passing to k-means. In that case, clusters will be formed, but cluster formation will be very very bad. And then we stuck at the accuracy point. I'm not having good results, we are not having good accuracy, we are not having good clusters or good output. So we have to prepare our data properly. So you can see that without k-means, centroid calculation includes 100. Cluster center shift towards 100. So cluster center, centroid will try to move itself in between. However, 100 has nothing to do with remaining data set. Okay, if we remove 100 with IQR analysis, actually this is the work of IQR analysis, this is the work of IQR technique. 100 will be removed before passing to k-means algorithm. So when we use k-means algorithm, then only this data set will be used, only this particular data set will be passed in k-means algorithm. Okay, with IQR, without IQR everything will be passed and its clusters will be formed. Okay, so without IQR this will happen, remaining points are not properly clustered. So obviously single abnormal value, single extreme outlier will affect performance of other clusters also. Okay, and if case B is k means with IQR, then 100 will be removed, remaining data will be passed to the algorithm, and then actual real genuine cluster centroid will be created, and depending upon that genuine cluster centroid, cluster center, multiple clusters will be formed. So this is the first step. Okay, by which way it is done, so you can see that. So these are different approaches, these are different aspects I have written here for understanding. I will share this presentation to all of you so that you will be able to work. Role of IQR analysis for outlier removal in clustering. Okay, in DBScan also we work on this. So whatever technique you are using, whether you are using K-means or K-medoids or DBScan or hierarchical clustering. In every technique, you will have to perform. You will have to work with IQR technique. Okay, so when it is okay to skip IQR, because there are certain scenarios where IQR analysis can be skipped. Okay, in case of, you can see large data sets, extreme points are few. If we are having a huge data set, and if we are having, for example, 1 million records, 1 trillion records, one huge some huge data sets, in that case the algorithm, the technique will detect outliers automatically. But in case of small data sets, it is advisable to implement it. Okay, so you can see, however, it is advisable to implement it for every scenario, whether small data or large data set. But if there are certain scenarios, if there are certain domains where we have to skip it, in that case we can take very huge data set. Okay, in very large data set we can skip. Okay, but it is recommended in every scenario, it is recommended small or noisy data sets. Now we will see by which way this is calculated. So very quickly I will cover this particular part. After that we will come to our algorithms. Okay, in interquartile range, first of all we have to calculate q1 and q3. Okay, first quartile and third quartile, q1 and q3. This is, for example, this is our data set. We have done sorting, and its median is, for example, its median is this one, 13. Median value is 13. Okay, so first quartile will be this one. So this is the method, this is mathematical approach. No need to perform it manually. Nowadays each and everything is available in programming languages, in programming scripts. So whether you are using Python or MATLAB or whatever it is, in that case you will be able to find out IQR. Okay, this is our data set. So sorting we have done. So very quickly I'm showing you its manual process. Okay, so median value is calculated. Once median is taken, after that median of lower half. What is median of lower half? What is median of upper half? This one, and this is the formula of IQR. Q3 minus Q1, 12. Okay, if you want to perform it with Python code, so this one. Now IQR is calculated 12. Now we want to see which particular value is outlier in this way, in this particular format. So for example, this one is our data set. What is lower bound? Lower bound is this. This is the formula of lower bound. Q1 minus 1.5 into IQR minus 10.5. Upper bound is this one, 37.5. Now we see which values are lower than minus 10.5 in our data set. Okay, in this particular data, no value. Which values are greater than 37.5? So what we have done, from a particular data set we have decided two bounds. One is lower bound and second is upper bound. It means, to clustering algorithm we will give the data after checking lower bound and upper bound, rather than giving entire data, rather than giving complete data. So in this particular data set we decide, in this particular data set we decide what is lower bound and what is upper bound, and this lower bound and upper bound is decided with the IQR. Okay, so upper bound is 37.5. There is no value beyond upper bound, so it means this data set is correct. If we want to make cluster from this data set using K-means or DBScan, we can do, no problem. But what about this data? In this particular data, you can see what is lower bound, minus 8.25, upper bound 33.75. Now 50 value, this particular value 50. Okay, So you can see that this upper bound is 33.75, and there is one data item that is beyond upper value, that is beyond upper bound acceptable. So what we will do, we will remove this value, and after that we will pass this particular data set to k-means, dbscan, or whatever it is. It means we will pre-process the data. First of all, we have pre-process the data, and after that we will pass it. Is this clear to all of you? Kindly confirm up to this point. Is it clear to all of you? In chat window, kindly confirm. Okay, so we have decided two bounds. One is lower bound, second is upper bound. Same thing, same implementation, same type of approach we use in image processing. Okay, which intensity images you are already having. For example, some images are very high intensity images, some images are very low intensity images. Okay, some particular formats you are having. So we decide whether it is, whether all of these, whether the complete data set is in a specific range or not. It should not happen that each and every type of that so many images we have taken from here and there, because specifically to new researchers it becomes very challenging. For example, I'm working on deep learning. Okay, in deep learning I have taken some images from internet, some images I have taken from my mobile phone, some images we have taken from a dslr camera. Okay, so some internet taken images. Okay, whatever images from taken from web portal, from benchmark sources. Some images I have shot from my mobile. So obviously whatever images we have taken from mobile phone, these are having different dimension, different intensity. Some images we have taken from some other source. Okay, so in that case, if we are trying to go for quantization or segmentation or whatever it is, you can imagine which type of results we will get. You will get the results, but quality of results will be very very bad. Now we will come to our algorithm. Okay, so this is the way, in this, but this is the code to find out the bounds. Okay, for example, so I'm opening Google Colab notebook, and in that in this I will show you how to find out this anomaly, how to find out the bounds. Okay, so this one, whatever data we have passed, and you can see that I am not implementing any clustering approach. It is only iqr analysis. Only with iqr we are able to identify that 50 is the outlier value. So after removing this 50 value, we will pass this particular data to our algorithm, k-means algorithm or dbscan or whatever it is. So this is the script. Okay, so this code, all of these scripts will be available to you at end of the session. So this IQR calculation, each and everything in detailed explanation I have mentioned here, you will be able to work out. Okay, now we are coming to our algorithms, core algorithms. K means algorithm, very first algorithm for cluster formation, and with some data sets I will try to take 2 to 3 data sets, different data sets, and then on those data sets we will implement k-means. In same way, dbscan algorithm we will perform with multiple data sets. In between we will discuss about knee approach, elbow technique, and knee approach to find out the best k value. In case of k-means algorithm, whatever data set we are having, first of all we have to decide how many clusters we want to form. We have to decide it before implementation of that approach. For example, this is our data set. Okay, very simple data set, and on this specific data set we want to form some clusters. Okay, so first of all we will see it manually, by which way manual calculations are done. Okay, marks in subject 1, marks in subject 2. We want to form two clusters. Now this is the major problem with k-means clustering. We have to decide number of clusters, two clusters, three clusters. But how to decide, how to verify whether only two clusters are sufficient or not? Okay, we will come to that part also. First of all, we decide initial centroid value, centroid point. Okay, it is a distance based approach. So for example, two clusters we have decided. Okay, so obviously, so as here we have decided that we want to make two clusters. Okay, so randomly we have taken two points, a 210, this one, and second is c 84, this one. Okay, first one is this one and second is this one. So it is just random. So randomly we have taken two center points, two centroids. Okay, and from these two centroids we will try to calculate other associations. So a and c, we will find out distance or association of other data items with these a and c. So this is the formula, Euclidean distance matrix. So x2 minus x1, this is very commonly used mathematical formula. And depending upon this one is the table. Okay, so a21, distance from this one is 0, distance from 84 is 8.49. So minimum distance to c1. B, this one minimum distance is C1. C, you can see it will be allocated to C2. So what we are doing? We are calculating the distance. For example, we want to find out whether F will be associated to A or C. So 6 minus 2 square, and after that of 10 minus 4 square. So this particular formula, and it's a square root. And this, with this particular calculation, this table will be generated. Okay, this type of output we will get, and then we will decide what will be the assigned cluster. Okay, after step 2, this one is the assigned cluster. Now once new clusters are associated, so this is the first phase. Now new centroid will be calculated. New centroid will be this one, very first value, 2 plus 2 plus 5. 2 plus 2 plus 5 divided by 3, it means means of this value. Means of y, 10 plus 5 plus 8. 10 plus 5 plus 8, it means new centroid will be 7.67. So previously we have discussed, just now we have discussed about IQR analysis. If we are not working on IQR analysis, in that case centroid will be taken, or centroid will consider that particular outlier also. Okay, distance will be calculated by consideration of that value also. So in now what will happen, new c1 will be this one. This is new c1, and new c2 is 8 plus 7 plus 6 divided by 3, 4 plus 5 plus 4, 4 divided by 3, and this one. So new centroid will be this one. Once we have taken new centroids, then again same step, recalculate distances till this particular cluster formation gets stabilized, till gets this particular cluster formation is stable. So we will keep on working on this particular process. Okay, so assigned cluster, and after that algorithm converged, it means no further cluster formations are going on, and then finally it is going on. So now we will see it with some implementation, with some practical demonstration. For example, this is our data set. So in multiple formats we will discuss with this particular value, and in multiple data sets. So how many clusters we want to form? Two clusters. So which particular data set we are having? This one is our data set. Okay, if you want to use some CSV sheet, that can also be done. And all of this algorithm is part of sklearn. Okay, in sklearn, scikit-learn dot cluster, this algorithm is available. Okay, import DBScan, import KMeans, import EM algorithm. Okay, so how many algorithms, how many clusters we want to form? Two clusters. We want to print centroids will be formed, and after that we want to visualize it. So you can see that this one, cluster formation. So these are the labels. So first two data points are in same label, are in same cluster. Last five data points in second label. What about the centroid? This one is the, these are the centroids. Okay, so these values. Now if you want to make three clusters, so we can write here, we can specify here how many number of clusters. If you want to see its documentation that is available, for example, so sklearn KMeans, in scikit-learn its documentation is available. Major part is that you should be aware with with the concept. Okay, in almost every session we focus and we motivate participants to understand the concept and associated concepts. Okay, as far as algorithm is concerned, as far as implementation is concerned, nowadays everything is available. All of these codes are available, each and everything is available, but we should be aware with different concepts that uh, if we are using IQR, then what will happen? If we are using a knee approach, then what will happen? Okay, so this one. Now if we want to make clusters on some particular CSV sheet, on some customer data, for example, we are having this particular data set. Okay, this is our Excel sheet, CSV sheet. Income group, age group, customer ID, and on this particular data set we want to go for cluster formation. And now the what is the major problem here? Okay, this data set is okay, code, that is also fine. Depending upon code, depending upon this particular attribute, age, income, cluster formation will be done. Okay, this one. So how many clusters we have given? We have given here three clusters. This is the major problem in K-means algorithm. This is major challenge in K-means. We have to decide number of clusters. We have to define number of clusters. Okay, so first of all I will run it, and after that I will show you. I will come to that part. Okay, so this Excel sheet, this CSV sheet, I am uploading customers.csv, and its clusters will be formed, no problem. So you can see that this is cluster formation, and it is a rainbow like chart. So this rainbow C map we have specified. So other color combinations you can mention. Okay, so these three clusters we have created. This one is under this particular label or under this particular cluster ID. But what is a major challenge, that how to decide the optimal number of clusters? If we are having a large data set or a realistic data set, then generally clusters are number of clusters are not predefined. Okay, in that case what we do? In that case we use a specific technique that is known as knee and elbow detection. K means clustering with knee and elbow detection. Okay, In Python, there is very popular library, very prominent library need with this particular name need to find out to analyze the curvature evaluation. Okay, so this particular curvature analysis. So this particular curve. Now, why I'm showing you this with k-means? In k-means, for example, we are having some particular data set. So we see at which particular point, at which specific point, there is big diversion. So knee approach or knee locator will decide the optimal number of clusters. It means with this particular approach, there is no need to specify value of k. Value of k will be decided with this particular package. Okay, so this one, first of all, I'm showing you in this particular graph. So what I mean to say, so that you will be able to understand. Okay, this is the graph, number of clusters k, and this is the WCSS inertia value. Now you can see that from this value, from this data point, okay, I'm showing you from this data point to this point, there is big diversion. You can see that there is big downfall. From this data point to this data point, there is big downfall. Now after 3, now you can see that 3, 4, 5, 6, from 3 to 9, there is no big downfall, there is no big diversion. Big diversion is from 1 to 2 and 2 to 3. After 3, it is getting stabilized. This is known as curvature analysis, curve analysis. So with knee approach, with knee and elbow detection, k value of k is decided automatically. Okay, so what it will do, knee will draw its curvature, this type of curve, and it will tell you that how many clusters can be formed, how many best clusters can be formed. So it is telling you that you can see that automatically detected best clusters is equal to 2, best k value is equal to 2. Okay, so you can see that from 1 to 2 there is big diversion. So you can see that this is, if we execute it, so this data set, customer data set, okay, and on this data, if you want to perform, okay, so need algorithm, need you will be, you can install. First of all, we have to install need package, pip install need. So it is available here. For example, your data set is in this way. Okay, so you can see that from 0 to 2 there is big diversion from so this is the cut. So this cut, so this particular line, you can see that it is deciding that after this it is getting stabilized, after this it is getting stabilized, after this point it is getting stabilized. Okay, same thing happening here. Okay, so need we have installed, and once it is installed, now you can see that it has decided automatically that elbow method for optimal k, and how many clusters can be formed, two clusters, and which are those two clusters, these are the two clusters. Okay, these are cluster formations. So you can see that we have not given value of k in k means. What we have given in k means best underscore k. You can see that if we are implementing k-means algorithm independently without knee, we have to give it manually, we have to specify 2, 3, 5, how many. But once we have implemented needle or this need approach, need with elbow, okay, You can see automatically detect elbow using knee locator. Now we are not giving here static value 2 2 3 4 whatever it is, we are giving here best k. So this is very effective technique for optimization. So if we are working on optimization in research, generally we work on optimization techniques. Okay, we go for optimal approaches, which is optimal. Okay, so that particular optimal value is calculated, is extracted with this particular parameter. Okay, so you can see that this data set and WCSS, and after that K means. In K means number of clusters is best K. What is best K? Best K is equal to need dot elbow, and automatically it will find out. Now if you want to perform, if you want to implement k-means on text data, that can also be done. You can see that k-means on text data. For example, you have sentiment data mining, you are working on some large language model. Nowadays we are working on, you might have seen lots of work is going on in large language models, in LLMs, in RAG, retrieval augmented generation, in generative AI. So in generative AI, such type of data is processed. Okay, not only numeric, some text data, document data. You want to train your PDF documents, you want to train your MS Word documents, images, and from those data sets of heterogeneous type, we want to form clusters. Okay, so this very simple data, we have created 5 to 6 statements. We want to create some clusters with k-means algorithm. Okay, so for that we use TF IDF approach. Okay, TF IDF for vectorization. In case of large language models, generative AI, nowadays we are, you might have seen in chat GPT, Gemini, Copilot, so many AI tools available. So in that, each and everything is stored in vector form. Okay, we want to convert this particular data in vector format. Okay, in numeric format. So on that also we will be able to form clusters. How many clusters we want to form? Two clusters. If you want to use here elbow and knee method, so in above, in this particular code, as we have put a code snippet, you can use, and once we execute, then we will be able to form the clusters. That document 1 is under cluster 1, document 2 under cluster 0, or whatever it is. Okay, okay, so you can explore it. I will share this presentation to all of you so that you will be able to work on it. Now we will come to our next algorithm, that is, so these techniques I have mentioned in this presentation: elbow and knee in clustering. What is use of elbow? What is by which way we have to calculate? Okay, in k-means algorithm, we have to choose number of clusters manually. If k is too small, then clusters are too broad. If k is too large, so it becomes very difficult manually to find out number of clusters, how many clusters to be formed. So if we are using elbow and knee method, then it will identify automatically. For example, this is our curve. This is a curvature analysis. So this is the elbow point, that after 3 or 3 onwards, it is getting stabilized, it is stable. Before it, there is big downfall, there is big diversion. When this particular diversion is complete, then there is a particular value we can take for optimal number of k. Okay, so these concepts I have mentioned here. Now, dear participants, we will come to our next algorithm, that is DBScan algorithm. So these things I have mentioned here in this presentation for your understanding. You will be able to Get it? DBScan algorithm, the density based approach, and this particular technique makes use of two base parameters. One is epsilon and second is minimum points required in a neighborhood to form a dense cluster. How many minimum points should be there? Okay, depending upon epsilon. Okay, one is epsilon, second is minimum points. In case of k means, we give only number of clusters randomly. Some particular clusters are associated randomly. Some data points are taken as a centroid, and after that calculations are done repeatedly till algorithm converge, till that particular cluster formation gets finished. In case of DBScan algorithm, we specify radius in form of epsilon and minimum number of points. By which way this calculation comes? Okay, first of all, we will see what are the categorizing points. Core points. So at least these number of points should be there. Noise points. Noise points, it means not part of any clusters, outliers. Okay, border points, fewer than minimum points but closer to our core point. It means some points are closer but not meeting the criteria of minimum points. For example, this is our data set. Okay, this one is our data set. In this, we have decided, for example, epsilon is 3. It means point should be in distance of 3, and in every cluster there should be 2 points. Okay, so cluster formed this one. So by which way it is done? This is our data set. Just for example, just for demonstration, this is our data set. By which way it is done? 3 is epsilon, minimum points is 2. From this, distance is calculated. Okay, what is distance? In same way, there are different types of distance metrics: city distance, Manhattan distance, Euclidean distance. So many distance metrics we will be able to use. Okay, so at each point we will see what is the association. Okay, so in this way, so a b c and up to f, how many core points are there? Okay, so this one, a is having one neighbor, not core, because minimum points are required. How many minimum points we have given? We have given at least two minimum points. So whatever value, whatever data point is fulfilling that specific criteria, only that will be taken as the core point. So this one is core, this one is core. Okay, so this, in this way, cluster formation will be taken. So now we have to decide which specific algorithm, which specific distance metrics we have to see. Okay, so I'm showing you that particular point. So in this data set also, for example, this one, Euclidean, in this epsilon 2, neighbor distance minimum points 2, p1 to p2. What is Euclidean distance between p1 to p2? This one, p1 to p3, this one. Okay, so we decide whether these should be neighbors or not. Okay, identify core points. How many neighbors are there? So p1 is having 3 neighbor points, p2 is having 3 neighbor points. So whether these are core or not. Okay, and once these are decided, after that we form specific clusters. Okay, so whatever data set you are having, okay, so I'm showing you that specific. Okay, so this one is the slide. Okay, So up to now we have seen with Euclidean distance matrix. So which other metrics you will be able to use? Manhattan distance, cosine similarity. So depending upon your research objectives, depending upon your goal, we can decide Minkowski distance, correlation distance, Hamming distance, Chebyshev, any of these. Now many times this question arise, for which particular data set we have to take or a specific distance matrix. You can see here, if we have geospatial data, numeric data, then Euclidean distance. If we have urban geography data, for example, you are working on IoT, you are working on internet of vehicles, IOV, okay, you are working on some path optimization, you are working on some optimization of route, in that case Manhattan distance, route optimization. Okay, if you are working on text database, text data set, sentiment data set, in that case cosine similarity. Okay, because on text data set generally we do not implement Euclidean distance matrix. For example, we are working on some large language model, we want to train some PDF documents, we want to give some doc files. In that case these classical distance metrics will not work. So we have to see which particular metrics, which specific distance metrics we have to apply. For text data, for sentiment data, cosine similarity matrix, because it is by default integrated with TF IDF values. Okay, so this one. Now we will see by which way we will be able to implement it. So one medical data we are having very this one is classical data. For example, this is our medical data. Okay, age, blood pressure, cholesterol, and this particular data, this specific data set, we want to pass to DBScan algorithm for clustering, for cluster formation, and so you can see mat.csv file we will upload from google.colab, import files. Okay, and here we have specified epsilon 0.92 minimum samples, and standard scaler is also required. This is also a part of data pre-processing. Okay, standard scaling normalization. Okay, one format or one way of data pre-processing is IQR analysis. After IQR analysis, after IQR filtering, what we do, we go for scaling of data. If we do not implement scaling of data, if we do not implement this particular technique, and it is applied everywhere, whether you are using K-means, DBScan, or any other algorithm, this block you will find generally. Why? Because in actual data set there is min max analysis. So what is there may be mismatch in min max. Mismatch means, for example, age is if I see quickly, 25 is minimum age, 72 is highest, largest. Here value is varying from 90 to 142, here 170 to 255. Now you can see min max of age is 25, 72, 90, 142, and 170 to 55. In this particular case, if we do not implement standard scaling, predict then cholesterol value will dominate, or cholesterol parameters may dominate the entire prediction because of the largest value. Okay, so all of these values should be in same range. Same range means This is my notepad. Okay, so just very quickly I'm showing you. So this is age, BP and cholesterol. So it should be in this way. For example, age, this one, it should be in this way. Okay, 25, it will be converted to 0.23. BP, it will be converted to 0.53. 170, it will be converted to 0.57. 28, just randomly I am writing in this way. Now this 28 will be converted by standard scaling. This 28 will be converted to a same range. It means, for example, one range we have given 0 to 1. So all values will be converted to 0 and 1 in a particular column. If in this way also, in this particular format also, BP value, it will be converted in same range. Cholesterol, all value will be available in same range. In this particular way, no parameter, no attribute will be able to dominate the prediction. Okay. Otherwise, if values are very large, if values are uh, mismatching, or you can say that having so much distance, in that case there may be problems in training and at the time of prediction. If we are working on clustering unsupervised approach, in that case also we face problems of cluster formation. So each and every value should be in same range. So this standard scaling will convert each and every value in same range, either 0 to 1 or -1 to 1 or 0 to 5, whatever you decide. Generally -1 to 1, okay, or 0 to 1. After that, we have passed it. Now we will upload this Excel sheet, mat.csv, and now you can see that this one, these are the clusters. Okay, if I want to see these scaling values, these scaled values, so you will see that what are the actual values and what about the scaled values. So print, these are the scaled values. Okay, so you can see that this one, what is the actual data? Actual data is this is the actual data, 25, 90, 170. This 25 is converted to -1.43. This 90 is converted to -1.50. This 170 is converted to this one. This is scaling. Now this particular, now clusters are formed on this particular data. Okay, not on this complete, not on this as it is data. After scaling, you can see that once it is scaled, then this particular DBScan is implemented on scaled data, because these values are having so much diversion. Cholesterol is having its own range, BP level is having its own range, age is having its own range. If you associate here Aadhaar card number, you can imagine what will happen. 12 digit Aadhaar card number. It is in that case, what will be the cluster formation? Okay, age is having its own range, Aadhaar is having its own range. So we have to scale down. This is known as pre-processing. Okay, once it is done, then we will be able to get it. In same way, if we want to go for some agriculture data, for example, we have some agriculture data depending upon rainfall, temperature, and soil pH value. We want to see whether some particular agriculture land is effective or suitable for agriculture of specific type of crops or not. That one, this one. So agriculture, okay, clusters. These are the clusters. Okay. So this one on numeric data. So three clusters for different agriculture zones: low rainfall and mild temperature, cluster 0; medium rainfall, warm temperature, cluster 1; high rainfall, hot temperature, cluster 2. Okay, so in this way, if you want to implement same thing, if you want to work on DBScan algorithm on this new text data, on language model data, on some specific document files, so this one, in this way, same format, and you can see that cluster, different clusters. For example, some specific data related to sentiments, some data set you have taken from e-commerce websites, Amazon, Flipkart, and you want to group it, you want to go for its cluster formation uh, with certain criteria. So in same way, but which additional approach we have integrated here, that is TFID vectorizer. Okay, TFID vectorizer sklearn. You can explore it. That is used for numeric for vector databases. Okay, so this one. If you want to work on training of documents, training of sentences, then you can go for it. So in this way, cluster 0 and cluster 1. No need to specify how many clusters we want to integrate. Only we have to give specific epsilon value and minimum points. If you want to work with some image data set, in that case you can go for it. Okay, you can, we generally implement K-means algorithm for image quantization. Okay, so if you want to go for that specific scenario, so these all of these code snippets available here, so you will be able to work on it. For so one example I'm showing you. For example, this is one image. Okay, on this particular image, this one is one image. Okay, on this image I want to implement K-means clustering. So it will be associated to a particular technique in image processing, that is known as image quantization. Okay, grouping of the pixels, grouping of pixels, and once we quantize this particular image, then we will be able to reduce the number of colors. Okay, for example, this one is the original image, and once it is quantized, we are, what we are doing here, we are doing quantization, but actually at the back end it is implementing K-means algorithm. Okay, at the back end, at the base level, it is implementing K-means algorithm. So by this way we come to know that whatever image processing techniques we implement at the backend, which specific technique we can deploy. So you can see image quantized with 5 colors. If I want to reduce it to 3 colors or to 4 colors or any specific number of colors, this one. Okay, whether you are using deep learning, machine learning, text data analysis, numeric data analysis, agriculture data, so you will be able to work. If you are working on video processing also, on video data also, you will be able to work on K-means DBScan. Okay, it looks vague that how it is possible that on video K-means is implemented, but what it will do, it will work on pixels, it will work on intensity level, it will work on specific dimensions